Welcome back to the lab, folks. So what I'm going to do today is I'm going to do a couple of little hacks. One is on this little pen light meter, this ANENG A3005A. I got a comment from a viewer about whether or not I was going to do the modification to it to turn on the backlight. And talking to the guy who's going to receive this as a gift and suggested that he come over and have a look at it. He did. And he said, yeah, that'd probably be good to have a backlight on all the time. But then, I did tell him that the backlight is probably going to run the batteries down. He tends to be a pretty frugal guy. So I'm going to look at the current draw and see what we can do here. Right here is a little 2N3904 transistor. And that turns on the backlight. So this goes up to the 3.1 volts. This comes here off the backlight itself, and then it just switches it to ground. The microcontroller just turns it on. This is the base, that's the emitter on this side, and that's the collector there. So I've got this little orange wire attached to the collector. So I have an idea here that if I find out how much current this thing draws and see then if we can bring it down a little bit and maybe even provide a 2-level light, that would be a really excellent solution. So we can see here that the meter is on. I'm going through this ammeter here, and I'm going through the amps range here to try and reduce the burden voltage to something insignificant. But we can read, it's got enough digits of accuracy here that we can see that just being turned on, it's consuming about, let's call it 1.3 milliamps. So if we turn on the backlight now, we can see that goes up to 10 times that. So having the backlight on all the time is going to take a 100-hour battery life down to 10 hours. And I don't think anybody wants that, especially if a guy like me who uses lithium batteries. I wouldn't like that at all. That's why I have this little wire here. What I'm going to do is I'm going to use this resistance box here. I'm going to connect it up between this wire here and ground. And then we're going to select a resistance that might be suitable for a reasonable backlight that might give you a little bit more contrast than what you typically get, which is this. Let's hook this up right now. I've got it set up for 100K there, so it shouldn't do anything off the bat. And we'll bring this around like this so we can see what's happening. So there we're at about 40K. We're just beginning to see some light come in. And there at 10K. That's pretty good. That really improves the backlight situation. So that's without it. And that's with it. I don't know if you can see it on the camera, but from where I'm standing, that truly improves the contrast. So that increases the current draw by about 0.6 milliamps. So it may take a 100-hour battery down to like an 85-hour battery. That's tolerable. And I think it's a good trade-off for having that increase in contrast here. And in the dark, that's going to be a lot better. Let me turn off the overhead lights. So it's quite dark in here right now. And you can see that provides a heck of a lot of lighting. And we can always turn on the backlight if we need more. So that, is almost blinding in this kind of light. But there might be situations where you want it. There's a problem. So that would be drawing current all the time because now the thing is shut off. So that would draw current all the time. That would be no good. Okay. Well, I guess I'm going to have to think about this hack a little bit. Yeah, I don't think there's a way I can do this. I'm thinking about this now, and there's no way I can actually do this. Let me bring the lights back up. Yeah, the other side of that transistor, the emitter, goes directly to ground, and that's where I've got this thing. So basically, I'm just bypassing collector to ground. So I'm not going to be able to do this hack. On the AN3007, you put in a resistor, it becomes an AN3008. And then there's a way then to turn on the backlight all the time. I think by really pressing this button for a long, long, long time or something like that. I just glanced over the stuff. But as it looks right now, this hack is a fail, unfortunately. All right. So the next hack I want to do, I got some of these lamps. In fact, I'm lighting my lab with them right now. And I like them quite a bit. So I ordered a couple more. I want to put them out. I want to put one out in my garden shed and I want to put one out in the wood shed. I did order them. They came in, they sent me the wrong voltage. I ordered the 110 volt ones, but they sent me the 220 volt ones. I wrote back to them. These aren't very expensive. They gave me my money back. But I'm going to have a look inside here to see if I can make them 110 volts. We've got it all back together again. Yeah, it's really too bad. when I was over there resoldering things, I took a little peek around. It looks like the thing actually turns on with a high side switch. So it's turning on through a PNP transistor. I thought, as I was searching through it, I thought maybe if it turns on with a low side switch, I could just bring that resistor down to the top of that low side switch rather than to the battery ground. And then we'd have a solution, but no, it doesn't look like that's going to be a possibility either. If anybody has any ideas, put them down in the comments. It would be interesting to get that to work. That's okay. I just gotta reheat these labels up, and they should stick down, no problem at all. This one looks like it's down pretty good. Okay, folks, moving on now to the lights. So first we've got to get them apart. That looks like a bridge rectifier. Actually, it looks like there's a resistor across it, but no capacitor. That's odd. Why would they put the resistor if there's no capacitor? But that's okay. And this doesn't look like a very good ground to me. So maybe what I can do with that is I can strip it off a little bit more, bring it over to this screw hole here, and when that screw goes in, it'll ground the case. Let me check these chips out. Okay, so these three chips here are SM1082Ds, and they are just a linear current sink. The way the resistors are set up here, all three of them parallel together, they're set up for about 75 milliamps. And when I look at the way these are laid out, these diodes here, you'll see that we have a group of 10 here, and they're in pairs. So this is parallel with that, that's parallel with this. And these are all in, then these groups are in series. Then it goes over here, there's a trace going over here, and then the same happens going down this way. And then there's a trace going over here, and this is in parallel with this, and this is in parallel with this, and so on down along the line. That would mean that each of these LEDs is having to take about 35 milliamps. That's quite a bit. Now what I'm thinking I can do is, I'm thinking if I cut this trace here, and I cut 1, 2, 3, 4, 5. So if I cut this trace and this trace, then what I can do is I can use some jumper wires, and I can parallel dot these 5 with these 5, and I can parallel this set of 20 with this set of 20 here, and that should bring the total voltage of the thing down to half of what it is. So let's have a look at what the voltage is across one of these diodes. I bet you it's around about 9 or 10 volts. Let me get a power supply up here. Okay, let's see what happens when I put this across here like that. Okay, comes on. We're at 9.7 volts. Then if we can do what I'm thinking, cut here, and here, and then wire them up to parallel them, we should get something that works at 110 volts. I did cut it here, and I cut it here and here, but this section parallel with this section, and this section parallel with this section. And just to be ultra happy with the amount of current going through here, I pulled one of these off here. So now we should have about 50 milliamps according to the documentation for the chip and those resistors. And since we have basically we've got 4 sets of LEDs in parallel with each other, so that should bring down the current to 1/4 of 50 or 12.5 milliamps through each LED chip. And that should make sure it's going to have a happy long life. It might not put out quite as much light, but it'll last forever. Let me just flip this over here, and we'll turn the power on it. Doing that because I don't want to upset the exposure on the camera. I still want to be able to read this current here. So let's turn it on. So we can see that they went on, and it's drawing 50 milliamps, and that's perfect. This hack was a success. Okay, let's see if we got that ground connection here. We'll put it onto the ground wire, and yep, case is now grounded. One hack didn't kind of work out for us, but the other one did. That's all I got for you today, guys. I hope you had some fun. I know I did. It was interesting. I'm a little sad that this didn't work out. I was kind of hopeful. I was going in the right direction at the beginning, but then, yeah, best laid plans of mice and men. This worked out just fine. I can now use these whenever I need them, and everything's just honky-dory. Thanks a lot for coming out. We'll see you in the next video. Bye-bye.